Okay, I think we're live now. I will just tweet the link and we can get started. Actually, let me grab my phone. It's the one professional. Okay, so this is a bit random stream. Like I wasn't really planning on streaming today, but I had some time, so why not? And in the previous stream, I said I was gonna look at the Cube software because they just like at the beginning of this week, I believe they added support for the STM32MP1 family. So I think that's useful to have a look at and see how that works. I had a bit of a look at that, but let's look a bit more. So let's see. If you never worked with Cube, it's quite an interesting tool from STM for configuring, or even just like it can help you to choose which MCU and now MPU also will help you will work best for you, but depending on your needs. As you can see here, they have, I'm not sure if it's all their MCUs, but it is a lot of them, at least the Cortex A and M. So you can here nicely filter based on your needs, like which peripherals do you need, or how much RAM, how much flash, packages. So you can filter out BGAs if that's above your soldering skills. But for today, we will look at the MP1 family, and then 157A in the BGA. Yes. So here we also have links to multiple data sheets and application notes, which are, I mean, it's the same as on their webpage, but here I think you can quicker jump between chips, and yes, it seems pretty convenient. So we start a project, and this software is written in Java, I believe, so it works, Java works everywhere, right? So it works on, at least on Linux, I know it works. I'm not sure about Mac, but I would guess so. But you know Java, so this is gonna take a second. Yep. So once this window opens, you'll be able to see you have a very nice overview of that chip. You will have the pinout, you will have all the peripherals, there we go. And you can see which peripherals are available on which pins. Like I clicked PI5, you can see what can be connected here. And if I go, let's see, system core, I will use external crystals. So if I enable crystal, then Cube will automatically mark the pins for the crystal as in use. And that helps, for me at least, it helps quite a lot with, like, it's a good overview of how you will have to route things and so on. So for crystals, obviously they are fixed to only one set of pins. You can't change that, at least on STMs, or at least on this chip. I'm not sure if maybe some other has that. So I mean, it's still a good overview. But for other peripherals that actually have alternative pin configurations, it's super helpful to see where they will end up and how you want to connect them. And yeah, I think it's really useful. And then later when you are done, you can generate projects just from your configuration with all the peripherals already set up and GPIOs and so on. So for Cortex-M, you can generate, let's see, they kind of changed this UI a bit. So I'm not sure if this is grayed out because it's not available for this chip or because I don't have those installed, but I would guess you don't need to have them installed to actually be able to generate. But for Cortex-M chips, usually you can go for makefile, and I think they've gotten a lot better, the makefiles. Like at the beginning when Cube was introduced, it was like you could see it was automatically generated and a lot of trash. Or not trash, but it was just, you know, like if you saved a Word document as HTML, you know, it's HTML, but it ain't pretty. But we will go back to that. So, or actually, I can mention, so for the Cortex, for the MPU, for this chip, it can actually generate a device tree for you, for Linux and for U-boot. And that's really helpful if you worked with DTS files before and different chips from various vendors. I'm just gonna check. YouTube is not receiving enough video to maintain smooth streaming. That is not good. Let me check that. I will move this here. Is something hogging the CPU more than usual? I mean, obviously Opera will. Yeah, OBS is, but that's to be expected. Sorry about this, but it is actually Cube. Cube is taking so much RAM. Thank you, Java. That's great. Can I really not stream Cube? That would be amazing. How is the stream? I will ask in the chat. Also, can someone tell me how is the audio? Because now I have the new microphone, but I've been told that it's still a bit like boomy and echoey. So I did adjust some settings that hopefully will fix it. I will also write that in the chat, just in case, I don't know, someone is not listening or can't understand me. And now I'm curious, maybe I can check. I can check the stream on my phone. I know this isn't very exciting right now, but I want to make sure that it's smooth recording, so it's probably worth it. Yeah, but if you ever worked with DTS files, you know that it can be sometimes a bit on the confusing side. So I think it can be really useful to have a generator. You probably don't want a generator. Okay, all good. That's good. That's good to hear. So I don't know why YouTube is saying that the stream might not be smooth, but I will trust you on that, and I'm checking it on my phone. I guess I can do some scrolling and so on. And then I will have to wait 20 seconds for that to actually show up in the stream. But yeah, the DTS generated by this also has some quirks, but I don't think you will use it like just copy it into your Linux tree. You will probably just copy the parts that are interesting and adjust them anyway. So it's a good starting point. I think it will be quite useful. Okay, now I cut up to the stream, it seems. It looks good. So whatever YouTube, hopefully. And yeah, so I will use both crystals as external. And there we are. We can see them here. One slow clock, high clock, or low speed. Right, I can close this if I can actually close this. Okay, I can minimize it as much as I can. Yeah, I will of course use DDR. I have decided already, I've been reviewing some, yeah, I've been thinking obviously about this board, so I thought that I will go for just one chip just because routing even just one RAM chip is challenge enough, so I won't go for two. And you can get like 512 megabytes of RAM, DDR3 RAM, still fairly cheaply, like €8 on Mouser. I think that's all right. So I'll go for one, and then I wasn't sure how much of RAM I'm gonna use, but since a lot of the DDR3 chips are actually pin compatible with themselves, I found two chips, and one was, like I say, 512 megs, and one was 256 megs. So I can experiment with either. I guess I will solder 512, and if I never use more than 256, I will just end up with 256. But you have to keep in mind that part of the RAM will be used by the GPU or the video memory, so that won't be accessible to the system. So 256 might quickly, cut in half, and 128 might be not enough. So with 512, I have a lot of left if I use 128 on the video RAM. But this is my first board with a GPU, so I'm not sure. Yeah, we'll just have to try and see. So let's give it a second. There we go. Right, so I was gonna show that when I selected the width, all the relevant DDR pins are now marked as used. So I think in system view, you can actually see them as a table. Or maybe not, maybe that's somewhere else. Maybe it's in... Yes, and as you can see here, list pinout compatible MCUs. That's also useful if while you're kind of designing which chip you want to see if there's maybe chip that you could use that's pin compatible but cheaper, like less flash or RAM, because maybe you don't want that much. Or you can just review your option. Let me just save this project. And really, no, I don't want to download right now because that's gonna take forever, because STM servers are not the fastest. So let's not do that. So I guess I might not be able to generate the DTS in today's stream because I would have to download. Or maybe I will leave it to download and then go to KiCad and start drawing up some things. But see, for example, here, I can see that the whole family of the MP1 is pin compatible as long as you use the BJ448. But I think all the packages are pin compatible within the whole family. Yeah. So if you choose a different package for this chip, it will also be all the MCUs. So that's quite useful, I think. Yeah, here we have the DDR pins. And for example, yeah, there's A15, which you don't need because it's 16 bits. So it's only gonna be, yeah, only half of that, which is good. And now you can see it's complaining. If I can see a tooltip, actually, it's not. But I believe it's complaining because the clock configuration is not updated because I changed to an external clocks. So here you might get a bit overwhelmed. I'm sure they'll do, but let's give it some time. Like, this is the whole clock tree, and STMs have a lot. Like, their clocks are very configurable, but also this is there's a lot of it. But for the most time, you don't really have to modify it. It's only if you wanna kind of clock down something, or if for some reason it calculates it wrong, so you have to adjust it. But for example, here, this is gonna be the high-speed external. So for now, this this clock tree here is set up for the internal high-speed crystal. And if I change to external, it actually, okay, doesn't change it because I think it's the same. So here I can actually, it gives me some flexibility in what frequency crystal I can use. So if I use 33, it's all good. And here I can change to external. That's correct, yes. So now you can see it actually recalculated everything. So, and the clocks for the peripherals that are not enabled are obviously not available right now, but the DDR should be, wasn't it like here? Yes, exactly. So 400 megahertz. I think it can actually go higher if I set 500. No, that is set up. That is fixed. So it doesn't really matter right now. But you can adjust some clocks if you need. But I will leave it as it is, and I think that should, yes, exactly. So now DDR is set up, and hopefully that's all you have to do. Mode, yeah. What else do we want to set up here? I still have to, I said it on last stream, I have to decide what I actually want on the board. It's gonna be a breakout, but not super generic. It's gonna be kind of specialized towards actually using this board as a base for the portable Linux board. So I don't want to break out everything. It's just what I need, and that's gonna help a lot also with the routing, because if I wanted to route everything, I don't think I would be able on 4 layers. It's just too many balls that you can't route between. But oh, that's interesting, because also I mentioned, I was wondering if RTC is a clock counter or is it a calendar, and it seems it's a clock, which is very nice, and it actually has a calendar. So you set a date and you're good to go. But in the end, it doesn't matter that much if you're using kernel, because then it takes care of the RTC for you. You just set it up and let it loose. And then interesting, I see here. So you set which, oh, okay, exclusive. So which peripherals, which MCU or MPU actually has access to the peripheral and can use it. So that's actually really nice that any, or at least I2C sees, but it seems a lot of the peripherals, okay, not Ethernet, can be used by either or. That's really nice. And then you can see here that you get a lot of configuration options. So it takes away a lot of the guesswork if you plan ahead. Mode gonna be 400, right? Yep. And then mode plus is 1,000. Correct. So yeah, you can configure all these things, and I think I'm not sure for the Cortex M4, but I guess it's similar, like as if you just had a Cortex M4, you get a C code that sets up all your peripherals. But for the A7s, you get a DTS. So nice. So this I2C is available on these pins, which is really nice because they're next to each other and they are, I mean, they're on the edge here on the outside, so really easy to route. So I2C2, I like you. I2C1, where is that available? Yeah, that's not so much fun. I mean, if these balls here are not used, then you're good to go, but there's ground. There's this quite interesting ground pattern here. So that one is not so fun. I guess just to test it, I should have at least one of each peripherals for each Cortex M4 and A7s. So I have the flexibility later in case I want to test something. Because I've been thinking about the Cortex M4, what can I actually use it for? Like, what would it be useful? Or because I'm not, I haven't chosen this chip because it has the coprocessor, although it is really nice to have it. Like I said, I want it because of the GPU and the DSI interface, DSI. But since it's there, why the heck not use it? And if you're familiar with my portable Linux board, I have the BlackBerry keyboard on it, but the BlackBerry keyboard is just like a matrix with columns and rows, and I don't remember, it has like 15 pins, so I didn't want to put that into the main CPU because originally I used the NRF52, which had like 30 GPIOs, so I didn't want to use half of the GPIOs just on the keyboard. So I have the STM32CubeMX, I believe, that I use for as a I2C slave to get the keyboard just on 3 pins, I2C and interact. But since here I have the Cortex M4 built in, I was actually considering using M4 to interface the keyboard, and it's also, I think, useful when you turn the device off and you want to wake it up on a key press, then you don't need to keep the A7 cores awake. You just have the Cortex M4 waiting for an interrupt, and that will wake up the main cores and boot up Linux or wake it up or whatever. So I think that's gonna be quite useful. So I will throw away the Cortex, the STM3220, or I don't quite remember which one it was, but I'll throw away that one, and instead I will use the built-in Cortex M4 here. I'm just hoping, or actually, never mind, because originally in that Linux board, like a year ago when I started working on it, I used Silicon Labs EFM32 I think, ZG, doesn't matter really, because it was cheaper and like it had just enough pins, and it was, I've never worked with Silicon Labs, or not much, so I wanted to try it out. But I spent so much time trying to get I2C slave working on it, and it just didn't want to work. So I finally gave up and I switched to the STM32, and on that one the I2C slave was a bit tricky, but I got it to work eventually. I was gonna say I hope I can get the I2C working on this Cortex M4, but I just realized they share hope they share memory. I mean, there is some buzz between the two, like the M4 and the A7, so I don't need I2C there. I will just find a way to have the keyboard that way without the I2C. That's gonna be quite interesting, I think, because yeah, working with a coprocessor might be nice. Yes, sorry, got distracted. And so I will need some GPIOs, like quite a few of them. But I'm hoping I can use the ones here on the bottom of the chip because, I mean, they would be easy to route. So hopefully I can just do that. And then the DDR is here. The USB I can see are here to the right, so that should be no problem to route. Crystals on the left, and then some UART, some SPI, some I2C just top left, and I believe I saw the DSI, there it is. So the debug and the DSI, there it is on the right. So that's actually really nice just placement of all the peripherals that will allow me, I think, to route them without crossing too many traces. I think that should be pretty nice. And yeah, when you design your board, I mean, you either go for like 6 or 8 layers and then your board can look however you want, or you're a bit limited with how the peripherals that you want to use are actually laid out on the board. So that kind of defines your board. But I think that should be fine, even if I think later for the Linux board, DSI would go up to the display, and then the keyboard would go down. So, and the USB also goes down because it's on the bottom. I think this will actually work out quite nice. I'm optimistic so far. We'll see. So let's keep going. We have one I2C for the A7. Yeah, that does it. There's so much. It's because it is the A7, right? Because for the M4, I think I could configure quite a lot because it generates C code. Yes, exactly. So you can pre-configure it like that. But for the A7, you do it in the DTS, and that's probably fine. Hopefully that or maybe they want, they could add it later so it generates more, because right now it will only generate the I2C node with these pins and that's it. But I mean, you can configure the speed, you can configure a lot more in DTS files, so they should have the options for that. But this is super early. I mean, these chips are not even, I think they're sampling right now. You can't order them. There's no decay or the discovery kit for it like publicly available anywhere. I actually tried reaching out to STM. Maybe I could get them to buy one earlier from them, because I'm doing this. I don't know if they care about stuff like that it's open source and kind of bringing some interest to their products. I don't know. We'll see. But okay, so there's one I2C. This I2C, what was it? It was kind of sucky. Yeah, this is not so nice. So let's keep searching. But as you can see, this is really useful for me right now because I can see exactly which balls this. Oh my gosh, this is really bad. Which balls the interesting. So this one can only be for the A7, and there's A7 secure, which I don't think I will have access to because I'm gonna use the 157 C. Oh, sorry, A. It's the C that has the extra security stuff. But it doesn't matter. So this one would have to be for the Cortex M4. Give it a second. Yep. And then potentially this one could be for the A7. This normally works faster. I think the streaming, like we showed even with Photoshop or KiCad, the streaming slows down just everything on my PC. And I'm not sure why. It's not the worst PC ever. I mean, there's a few cores. They're not doing much. 16 gigs. I mean, half of it is taken. I'm not sure. It's just, it takes a lot of resources to stream. So let's see which this one is assigned to. Or did I already check? No, this is not. Was that? No. Where did it appear? Oh no, nowhere, because I have to select it. Not perfect, but it could do. But let's keep searching. I'm not sure. I don't think there's a better way. Someone might say you should do it differently. Maybe then you can see all of them. But okay, that's a lot better. So that's a second, unless C6 is I2 C6 is any better. Nope, it's not. So we have our winners. There we go. And this is perfect. Yes, I could actually go. Doesn't matter. So this way I can have one I2C for the A7 and one for the M4, or just in case I can actually have both in either, because I haven't really decided what I will use them for. Right now I don't have, or actually the PMEC will use I2C, so I think I will have to add one more I2C just for the PMEC, and then the two other ones I can have on the board for whatever. Oh yeah, the STM32MC, that's gonna be interesting. Where is that? Let's not get ahead of ourselves. So this is good. I think you can add a custom label to things that would be useful for myself. So maybe not. We changed this UI quite a lot. I could add a custom constant, but that's kind of silly way to do it. Yeah, it doesn't look like I can actually do that, but it doesn't matter much. Okay. So 1, 2, and then one more for the PMEC. I guess the ones that were here could go for the PMEC. Where was it? No, not that one. So that's 3. Not. Wait, was that 3 again? How did I click? Oh, it's really slow. Or this could do. I should have paid more attention. And then 6. Yeah, this could do as well. And lastly, no. So not 1. It was. Oh yeah, 6, definitely. That's a nice and easy one. Right, so this is 1, 2, or zoom in. Yes, I don't know if you can see because my resolution is a bit low. So this will be 1 I2C pair, and this is 4, and this is 6. So I can use, I don't know, like 2 and 4 for as headers, and then 6 for the PMEC. So that looks good so far. I'm really surprised you can't. Sure. Yes. Value is not valid. What? Okay, right. Sure. I wonder how that appears in the DTS. Okay, the Quad SPI. I'm not sure I'm gonna use, unless, and that's something I have to consider, because I have been planning to put a FPGA also on the board, but I'm a bit struggling with why I want to use it, because I'm kind of noobish in FPGA territory, so I'm not I'm not sure what you can do with them. So what would be a useful thing to, what a use case for this, and how it should be connected to the actual CPU. Like, I've been planning to have pins go from the CPU to the FPGA and then out from the FPGA to the PMODs, so you can modify any of the signals or translate or something like that. But I'm still not sure how that will go. So another idea was to actually connect the FPGA to the quad SPI, because I believe the quad SPI can be used, it's memory mapped. So then the FPGA would have access, would share memory with the CPU, and that's useful. You could do some cool stuff there. Again, I'm not sure what. So I would be really happy if someone would come up with ideas. I know I'm offloading work on the viewers, but I mean, if I'm gonna release this, then I'm hoping it could be useful. So yeah, let me know if you're in the chat now or watching later. Tweet at me. I'm open. I'm always happy to discuss stuff like that. So let's assume we will put it, just to see for now where it is. And it also has access to both. That's really cool. So bank 1. Oh no, that's not so much fun. That's like you have to have traces under or to the side. Yeah. Bank 2, is that a different? Oh, that is different IOs. Interesting. And then dual bank is just all of them, isn't it? Yeah. So again, I wish there was a way to highlight this here, and then all these, and that one. Yep, and that should be yes, one IO block, and then the other 3 IOs. Yeah. With CS, I think you could do software CS, and then you wouldn't have to use that pin. I could just select something here. I wonder if you can use alternative pins. Right. Can I change it? It does not appear that I can change. Nope. So that's a bit sucky, but I mean, as long as they are here, it's just one line to pull here, so maybe it won't be the end of the world. Let's leave it like this for now. Right. And then there's 3 STM-MCs. I do need at least one, obviously, for the SD card. Then I'm still battling a bit. If you follow on Twitter, I have bought the 8 devices Wi-Fi/BLE module, and it is using SDIO. Oh, there it was. So I've been trying to get that work on my SAM A5 board. I have had some problems, which I believe is because I have the SDIO as just pins, and then I connected that with wires in the air, high speed, bus. It's not the best. I did put pull-ups there, but it works sometimes, which tells me the software seems to be okay. It's more the hardware parts. I'm hoping that if I add a proper footprint for the module on the board, and yeah, just slap it in there, it will just work. But that's also famous last words. So yeah, this is the module. It's quite nice. As you can see, it has BLE 5.0 with, like, if you do a firmware update on the chip, the Qualcomm chip there, and it's a dual band antenna. So a nice module. There is a blue version of this which uses USB. It's the same it's the same chip family. It's just a different variant that goes over USB, and that is an option, except there is only one USB host peripheral on in this STM chip. I would have to put a USB hub chip, and that's kind of annoying. So I'm trying to avoid that, but yeah, let's see. Yeah, so that's my issue right now. So I do need two SD interfaces. And they're all on. Oh, wow, this one has actually access to MDM4, which I don't need, but it's really cool. Let's see. SD4. That's not, oh no, wait, there was. Something appeared here, right? Or is it that just me? Nope, that's just me. Okay, so everything is self-contained here. That's, or like not on this side. That's good. That's nice. About this one. Wait. Seriously, clicked it like 3 times or something. Voltage converter, that is quite interesting, because this module can go either 3.3 or 1.8 volts. So if I could go 1.8, that might be, ooh, that's really nice. That might be useful. This one is even better than the other one. Yeah, it's just here. So let's try where this one is. Oh, that is quite nice, I would say, because then they are just both next to each other. And oh, the I2C is in there, but I think you can escape it kind of under. It should be fine. I can't see which is the which, but 2 2 2 2 3 3 3 3 3 3. That's pretty good actually, and that's 2 also, right? So 1 2 3 4 5 6. 1 2 3 4 5 6. Yeah, this actually could escape this side also, assuming this isn't something. Yep. Oh. Does that add more pins? It does, because then you have the. Right, that's not something. I think let's keep it at this and assume that's correct. Yeah, so that's gonna be those two. So good so far. There's still a lot of space. Did we miss something here? There's scan, which I don't care about. FMC. Can't it do only flash? What FMC? It's the flexible memory controller. It can actually also do quad SPI, but I guess that's its own thing. So we'll see about that later. And then SPIs, in the current, let portable Linux board, I use SPI to drive the display, and at 80 megahertz, I believe, which is, it's quite alright. I get at least 30 FPS because the display resolution is not that big. It's 320 by 240. So, I mean, your kind of standard resolution. And at 2.6 inches, it's not that bad, but you can always go higher. And that's part of the reason that I'm trying to get DSI here, because the display used in the BlackBerry, what was it? Q10, Q5, and like the BlackBerry Classic, it's all the same display, the 3.1 inch, 720 by 720. It's a nice square one. Uses DSI, so that's why I want to try this with this board. If I could get it working with that display, then we almost have a BlackBerry, which is not really the target, but they just seem to have similar taste in parts to me. So why not keep going? And the interesting thing is that this SPI, I think 18-bit color, 320 by 240 display, it costs me like $9, and the way nicer, higher resolution and larger, like physically, BlackBerry display was, I think, $7, and that's a replacement for the BlackBerry. So it actually comes with a front panel which has touch, and I'm not sure if it has like a speaker or a vibrator, but possibly. So yeah, it's cheaper and it's easy to get for now. I mean, obviously the stock is gonna run out at some point, but for now we're good. So yeah, that's the plan. So I won't need any SPI for the display, but I think it's still good to have two SPIs just to have them just in case, because yeah, the board design is not finalized. So after I do this breakout I might want to add more stuff to the board, like maybe some sensors, maybe like an axle or a gyro, just for fun. Yeah, I haven't really thought what else could be there. So okay, let's go SPI hunting. Let's see which pins are nice pins. This will get more confusing as we go, because I have to kind of track which pins actually are appearing. So okay, so it was 1, 2, 3. Shouldn't we have? Where's the CS? Lock me some OC. Does that? Okay, so we can't have a hardware CS. That's not available in this context. But it isn't master move. What's your problem, bro? I mean, have duplex will just remove. Yeah, that's fun. Okay, but then I mean, there's so many GPS here that probably won't be used. I can just spare one as CS, but I have to remember, and I think I will, because once I actually create a header for it, I'm like, yeah, where's the CS? So this looks good so far. That one would be for the A7. It would be nice if the ones I choose both work for both. This way I can yeah, decide later what I want to use them for. Let's see this one. These two were nice, but this one, was it that one? Yeah, that's not so great. So not for now. That one also looks like there was one. Oh my gosh, why is it so hard to keep right there? So this one and like somewhere here. So that's also not so great. Let's keep searching. maybe we can have a nicer one. I'm sure this is not making for the most interesting stream, but this is, I mean, this is what you kind of have to do when you design. Oh, that was nice. So it's 1, 2, and 3. This one is quite nice, but let's see still. This is when, kind of what you have to do when you make a board. You have to decide which pins to use, where are the peripherals available. Like if this was somehow an NRF chip where any peripheral, almost any peripheral can be set on any pins, that would make my life a lot easier, but I'm not aware if you get that excuse me, you get that in MPUs like this. This SAM A5 had the Flexcom, which was quite nice because it could be either SPI, I2C, or UART. Except, kind of sucky thing about that was it had to be decided at boot time, like in the DTS. And you can use overlays, sure, but it would require a reboot if you want to change it. That was kind of sucky. But then here, there is no such flexible interface at all. So SPI will always be SPI, or it can be GPIO. You know, it can't be I2C. So you have to decide. Oh, that's spread out. That's not nice. Okay, last chance. Prove your worth. And I lost it. Was it down? No, it was here. I really wish there was some way to like highlight. Wait, SPI5. Oh my gosh, I'm so something. Okay. Can I do no regex? This is gonna be so much useful. It's much better. 4, 5. 5 is out. And then 6 can only be on. Oh wait, can I do this without? Nope. I have to actually set it. So yeah, let's see. No, that's not good. Okay, so SPI1 and SPI4. SPI1. That's quite alright. SPI4 and then 2 and 3. That's pretty good. Then you have DDR address and DDR data. Oh, it's also highlighting. Right, because that one, it's only that. It doesn't have to be enabled even. But that's all. That's all good. Excuse me. I just have a sip of something. And then UARTs. UARTs, you want obviously one for the console, for U-boot and all that good stuff, or not so good, depends if you like U-boot. But for the kernel logs and so on, and then I actually need 2 UARTs. Maybe not, but oh no, actually I need one for the Bluetooth, because on the 8 devices module, the Wi-Fi is over SDIO and the Bluetooth is over serial over HCI. So I need 2 or 3. Luckily it's 2 pins, so it should be, yeah, because I'm not gonna use the hardware flow control. It's only 2 pins, so it should be together, hopefully. And yeah, let's see. So that one's not in the bootloader, so we don't want that one. And then USART. Oh, none of them are. But one of them was in the bootloader. Nope, don't matter. That's quite alright. That's one UART. Nice. That's alright, although it's a bit far. So let's take like far from this one. Although it's next to the SDIO, which the module will be. So maybe this is actually quite alright. Oops, word. Okay, it's sprinkled there, so let's skip that one. And that's here. So that's quite alright. So if we can go for 3 later if I have a hard time routing all this, but I think it's looking pretty alright so far. I can remove one of them. Yeah. So I mentioned there's only one USB host. There are 2 here, but I believe there was some limitation on that. So let's see if I've enabled that one. That's a host. There it is. This is strange font, but alright. Exactly. So I can have either 2 hosts or 1 host and 1 OTG. That was the problem. And obviously I want an OTG, and I don't know if I want the host in the final device, because I probably want just one like USB Type-C on the bottom that will be OTG, which actually, how does that work on OTG on USB Type-C? I'm sure there's a way. Oh yeah, it's the CC pin. Yeah, we'll look into that later. So yeah, for this board I probably want both, and then I can also use one just for power right now. So, ooh, interesting. And how does that? See, that actually answered my question. So on Type C, there's no ID pin, and yeah, there's something else, I guess. It negotiates or something. DBus. Oh my gosh, I used to remember what this was for. Was that for controlling the... we'll get back to that. It's not so important right now. So yeah, that would be the connectivity peripherals. Oh, that's never mind. So right now we have 2 I2Cs just available. One for the PMIC, a third one for the PMIC. One SPI, which could be either a SPI chip or to the FPGA, that to be decided. One SD card, one SDIO for the Wi-Fi, 2 SPIs, 2 UARTs, and a third UART for the Bluetooth, and then USB host and USB OTG Type-C. So that's quite good. Then the GPIOs, I will decide that lastly, because there might be some stuff I want to use here. Like I would like sound, so that's something to look into. Hardware semaphores, Intel processor, yes. Watchdogs, not so relevant right now. Timers, not relevant. Yeah, that's where we were. Security, nope. was the delta sigma? The digital filter for sigma delta modulator. Yes. Free RTOS. And then the debug, of course, can do. You know, that's a bit confusing. If I have a JTAG, what about the Cortex M4? And if I enable Cortex M4, it's the same pins, isn't it? But I mean, Cortex M4 you usually flash over ST-Link, not really JTAGs. So yeah, exactly, these double. Have to again read up on that, but we do need these. The fifth pin is here. The reset, probably not, because we will have custom reset logic from the PMIC anyway. Yes. What was this? I mean, short description. Great. Power. Yes. Please give me power. Okay. Could this actually be it? That seems very little. I know I will probably regret these words later, but right now this looks pretty good, I say. There's a lot of GPIOs left, and all of these. Where was the sound? It was the. Oh, there. Wait, did I miss this whole? Yep. Source. Camera. Don't need the camera, but need the DSI, which is here. Oh. Yeah, the clocks. Yes, fix them. Because we enabled new peripherals, I think stuff got modified here. I will also save because I never trust software. All right. Interesting that. Why would it go so slow? 32 was PC from because as you can see here, I hope if I zoom in, SPI 4 and 5 only run at 64 megahertz, and then SPI 1 is at 160. But actually then I have only only two SPIs. 1 and 4. Right. 1 and 4, and the 5 is there always. Yes. Where's the peak clock 2? Can I search in this? I don't see that. There it is, peak clock 2. I mean, that's gonna only lower it times 1. Internal. So that was still not using the external clock. Let's see. There we go. That should, yeah, that's now it's 100. So that fixes it, but it's still not perfect, and I think we could actually do it even better. This is probably not a very, no. What is the max? 104. Okay, so that's actually how fast SPI 4 can go. Can go 104.5 max. So that's good to know. And that one takes from PLL4P, which is again somewhere. I hope no one is streaming at the screen. It's right there. No, it doesn't matter so much right now. That's better. But SPI. That's better. Even better. Wow, can actually go that. Nice. So yeah, hopefully, yeah, these configs work. Because there is a lot here. But later in the DTS, we can verify all that stuff. What is complaining now? There was something complaining there. LTDC must be configured. Oh, there it is. Right, that was the problem. So, your 24-bit. There it is. I think the clocks were also, see now they're broken again. Don't matter, video mode, and then that should, yep. Clock, second lane. So there's 2 lanes and the clock. Perfect, GPU, yes please. That probably just adds a node in the DTS. Then CC, we don't need serial audio or I2. That is something else I have to look at, because in the SAM A5 you got a like differential output that was just what was it? I don't quite remember, but it wasn't a serial interface for audio, so I need to decide which one I want, which is better. That is yet to be decided, but I2S shouldn't have that many pins, and either is fine. Oh, no problem. Probably the clocks. Yep. As you can see, the clock resolver is so-so. Sorry, just waiting for that one. Yeah, but I think it tolerates my changes. Like, it doesn't touch them unless it really has to. -3, that's too fast. 4. Oh yeah, that's what it has to be. Although you can times it. Pixel clock 80 megahertz. That's quite alright. It's 2 lanes. Then here it's complaining about. No, it's not. I just had to change. So this is, I think, going quite alright. Now we have the DSI, we have the display. Let's take it like here. There's something else. For the DDR, do I have to manually enable the reference stuff? Doesn't look like it. Oops. I wonder how we configure the pin bit swapping. That's to be. We can figure that later. So ADC deck. Yeah, do we need any ADC? Yes, not. Not that I can think of right now. So yeah, let's. Is this digital temperature sensor? That's probably built in, isn't it? Yeah. So let's assume this is correct. Right. And then a few more GPIOs there. But if I did, where do you? Should be a list that I can export. CSV. I mean, that's one way to do it. Yes, that's quite all right. I thought there was a nicer, even nicer way to do that. That one, tools. Oh yeah, because Cube is also quite nice for estimating power usage on the chips they offer, because they have models and values, power and consumption values for different different chips of theirs. Wow, that's now I'm curious. No, well, these are not so perfect in my use case. But yeah, you can have, which peripherals you're running, what is exactly the state of your CPU, and that should tell you the consumption. And add instead, yeah, probably need to choose more and more. Let's see that one. Exactly. So you have the consumption here, 265 milliamps. That is a lot, but it's also running at full speed and so on. That probably won't be the case all the time. Yeah. It's a folder inside a folder inside a folder. It gave me a PDF. Whoa, that's oh, that's actually really nice. I think I used this before. You got this whole report with the balls and all the pin configurations, and oh, that's really bad. But the crystal, the clock tree. Yeah, this is nice for people who like their data tables and such. But I think this should be really helpful for for KiCad. Except this is not how I'm gonna do it really, but I can move that later, so should all point the other way. Yeah. I can assign now and then later I divide it into those hierarchical. Never mind. So just so you and I can also on the way verify the pin numbers that are actually correct. So this is nice. And then on page 5, and it's A2, that's correct. And page 4 is A3, correct. P13, wow, that's going to be a lot of jumping because it's sorted by. What is that sorted by? It's like balls, but only the ones that are used, right? Interesting, it's showing me one viewer, and I'm wondering if that's just me watching the live stream or is someone still with me? Speak up. So PE13, which should be A4, and it is. That's really good. So good so far. Would it be nice if you could kind of have different colors so then you could see everything and just, you know, have a quick look and see where stuff is. You can obviously have different types of labels, but then you only have 3 types. That's not so useful. The colors would be nice. I think I heard there is support for colored rat's nest in in KiCad it's coming, in PCB new, but that's just the rat's nest. I think the schematic could use that as well, and there are, I think, already options for when you draw the lines to actually have. Hope it doesn't crash. There it is. I mean, look at this. This widget is already there, so it shouldn't be that much work to have it per label. And for backwards compatibility, yes, have black if it's missing the information. So yeah, someone get on that. PD5. I think I'll just do all those traces on all of them, or at least on the ones I moved. Then I don't have to keep switching between wire and label. Okay, PD5, which is A9, that is very correct. Perfect. Well, PD5, why is it blue? What did I do? Because I added a text instead of label. Yeah, the text doesn't have a color either. Yeah, it doesn't. So that could be another thing, that the color, just like the line, could have a thing. I should start writing these suggestions down, and maybe I can eventually get to them. Then P3, A10, correct. There we go. PB3, A12, correct. So good so far. PB14, which is A13, that's still correct. Yes, mono IO. What do they mean by that? Right. I gotta. Yeah, because it has its own. So that's actually not so useful here because obviously it is what it is. But I can still put the labels to know that I thought about it and actually to verify the pins. P0N, correct. Clock is A16. That it is. Oh my gosh, KiCad. Oh. Good, I saved fairly recently, I guess. Okay, Crush, that's number 2. I think the first one was in the first stream. Isn't that fun? Yeah, I just wrote in the chat so I know when that happens. Amazing. So that's why I save all the freaking time, because you just can't trust KiCad. Okay, I have that one. Now I don't know where I was. I was PD5. I mean, if you can't trust your tool to not crash, and that's not so fun. It just gives you anxiety. Don't need that. Don't need more of that. But luckily we can quickly recover. Yeah, I wonder what the crash counter will be by the end of this stream. The crash counter 2, I guess. Should I put it up? That's not that's the word I'm looking for. Let's not taunt it. Crash even more. So I confirmed this one. And save. Yeah, I can rename that later. I don't need the host in there. Clock on A16. Yes. 17. Correct. Then, since we're already here, 0P on B15. Clock positive B16, that is very correct. And data on B17. All right, that is good. That's correct. H, I haven't moved there. And there. I really like this insert trick. I mean, it's such a time saver, especially when it crashes and you have to do it again. PH14, C2. Wait. There's so many IO banks on this. Where's H? Excuse me. Looking for PH. How did it end up here? EFG. Yep. Yeah, I'm still trying to figure out this whole stream thing. Like we had Adrian was it yesterday? No, on Wednesday. That was quite fun because I had someone to talk with, and he can talk about his projects, and we could show a bit of that, and this keeps the stream interesting. But I mean, it is a bit distracting and it takes my time, but it might be worth in the long run. So I'm still trying to find the right balance, because just me talking all the time is boring, and silence is boring as well. So, oh no, I stopped checking the ball names. I'm trying to find ways to make this entertaining in some way, while also staying productive, because yeah, it's already taking a while. PB4, P13, correct. And say you are 4. So again, if someone has ideas how to improve the stream, I'm all ears. D3, E1, play, E7, me jumping around. D15, which is D10, that is correct. G6, which is D11, that is as well correct. Also correct. This is actually, I like this. It allows me to verify the ball assignments, because there's a lot of them, so mistakes might be made. And this might help catch some of them. So also at one point I'll have to not centered. Oh, that's like per unit. A bit annoying. So yeah, there's a lot of work that goes into making a nice schematic, and some people are not as perfectionist as me. I'm a bit, I don't know if it's OCD, but I'm a bit anal about this. And I know it's not that important, but I kind of like it a certain way. I think it makes it clearer in the long run, and I've seen my share of bad schematics. I'm trying to keep away from that and save. I'm saving even more, because that crash, I haven't had it crash for some time, and now I'm just disappointed. So yeah, that's some of them. I will probably, no, maybe not. Because I was thinking if I will have to transform these into these guys later, if I put them in separate sheets, but probably these banks will be next to the actual actual device that uses it. So that's all good. The bug is, I had it somewhere, like here. JTDI on D16, and I need traces first. Or is it called wires? Because it's not. TDI. So interesting that I have the name wrong here. But I follow the datasheet, so I'm not sure if I missed it or yeah, if I missed it or it's different in the datasheet, doesn't matter. Mm, 12. There we go. I'm hoping to finish this, and I'm not sure because I'm locking in 1 hour 30 now. So let's try 30 more minutes and see where we are. Don't wanna make these too long. Not like the first one. EC12. I'm getting a bit confused with these, but on E12 that's correct. Perfect. Save it. This is way easier to keep track of than the datasheet was. Here, E16, correct. So good so far. And then some DDR stuff, which is here, and there is a lot of it. And it will be in its own sheets, no stress there. And insert it. I'm just holding insert and it keeps adding them. But you can only see them actually when I release, and that's not the stream, that's just how it is. Yes. There's 3 on E20 and everything is fine. Now we will go into the annoying part of rotating each damn label. Oops. But it could be worse. So while I'm here, A7 should be on. That's correct. Reset I put here. Still correct. F21. Correct. Grogard, hello. Sorry, I just now noticed you. Thank you for joining, our returning viewer. To catch you up quickly, I use the CubeMX software to configure the peripherals that I'm gonna use. What am I? It's here. So I see which balls are used by which peripherals, so I can select the peripherals that are the best for routing. So I'm pretty happy with the selection. There might be more peripherals that I forgot, but so good so far. So Cube generated this PDF for me that has table of the pins. So now I'm marking the pins I'm gonna use. And also DDR. I'm marking that in KiCad, like labeling them. And also this helps me verify the actual balls that are correct. So it's very nice. So that has been the last 1 hour 30 minutes. I explained Cube a bit, if someone has never used it. And yeah, and now you're up to date. yeah, it's quite useful. It's also really nice that Cube generates a DTS file for you with the settings that you actually set here. And that's gonna be really useful, I think, later with Bring Up. Because, yeah, sometimes DTS can be confusing and you have to check, like, reference DTS for like some dev board from the manufacturer, and it's not always clear why something is like what it is. So I'm hoping Cube will actually make it clearer. And it's also really nice because I discovered that, well, Cube showed me that some peripherals can be accessed from either core like M4 or the A7, but not all of them. So I actually went ahead and now I can find one that's like this is exclusive only to A7. So this also allowed me to yeah, choose the ones that I can use on either, because for now I'm not sure what I'm gonna use it for. But that's Microchip slash Atmel have one for the SAM A5, because maybe I didn't look hard enough, but I didn't find one. F4. I mean, a lot of my board was actually based on their mod system on modules, so a lot of the pinout was also copied there. That way I made sure that it will actually work. I think my voice is giving giving up, whatever. I've been speaking a lot on these streams. Oh, I did this one already, and I did that one. I haven't done that one. Port Z, that is just amazing that there's so many. I mean, it doesn't go through all the letters, but there is a Z, so that's cool. Yeah, which port is your GPIO? Or it's just on the Z port, no deal, no big deal. Yeah, page 4. Should I check how many pages there are? 7, 8, oh my. I should have not checked. There's 6 more pages. So I might not finish this today. So we just did 4. What else is up, Grogard? What are you working on? Still working on the U-boot overlay stuff? Oh no, you were porting the PMIC code into U-boot. How is that going? DDR, that's here. Oh, but is it the PMIC lacking the functionality, or is it the driver? Yep. All right. Nice. What was the problem? Can you describe it a bit? That was a short page. That's all right. Yeah, Grogart, can you tell me how is the audio today? Because I tweaked some microphone settings, so it wouldn't be like I removed some low frequencies. Hopefully, sounds better. Like it's not as boomy and echoey. So let me know. Right, battery charging from U-boot. Nice. Yeah, I mean, as long as it's all right if it's charging until the system restarts, then that's all right. But I guess that shouldn't be a problem. This is actually going pretty fast, and I'm checking the pins also, so this is all right. It's not in use. Okay, but even so, disabling even if the battery is not there, or if it's there but you don't want to charge it, because I mean normally you charge it like all the time. Right. But then I'm wondering, I don't know, right? I guess you write to some sys file to config.fs, and that disables it in the PMIC. So the user just writes different value there, and that will enable it. Right, so that's a bit strange that it will actually try to charge if the battery is not there, but I'm not 100% sure how that exactly works. All the battery logic, so maybe, oh, hello. No, that's I had one KiCad crash today so far, so now I'm saving after each operation. That's all right. These pages are not so full, so doing pretty all right on time. Right, I was gonna double check because these ends should just be strike throughs or overscores, not ends, just to keep it consistent, because these are positive and negative, but here that's just active low, so I should be consistent. But I'll just, or I can actually add a note. There we go. I'm sure I will understand that in a week. So much DDR stuff. It is a lot of pins. I'm so curious if this board will work, because DDR and then DDR3, that is high speed stuff. I don't need it to work at full speed immediately, but having to work at some frequency, that would be really nice if it works. I get sloppy at checking here. So clock N 21, 20, okay, and 12, 19, yes, we're back. And the clocks were here. Yeah, for sure. Trace length matching, but still scary. Yeah, I have actually JLC started. JLC now has option to select which stack up you want for their boards for 4 layers, and they have the info on the stack up, so you can actually do some proper impedance calculations if you feel like it. If you go 4 layers, there's impedance, no impedance, or impedance yes, and then you have the 2 stack ups, and I believe this will take us to the stack up page, or not. There was it in capability, or was it here? Yeah, so that, I think that will take us. Yes, exactly. So here you have actually all the stack ups for different thicknesses, and this is actually now really nice. Like, it gives you proper info for calculating this. So that's quite nice of them. Yeah, I have a problem. I should seek help for all this very precise way of doing schematic, but oh well. There we go. Yeah, but I mean, there is a calculator for the trace width as well, so yeah, like, you can plan even better with knowing the stack up and all that good stuff. P1 in. No, I pressed P. Oh, why? I don't want to stop it because if it crashes. So yeah, I think actually while this is happening, I could start the download here, and hopefully that doesn't kill the stream too much. So I want to generate code. Yeah. So let's see how the stream is doing while I download this. And that support package will allow me to actually generate the DTS file, so we can have a quick look at that, how that worked out. I will end up renaming most of these for now, but this is still more for initial, just seeing which pins are available, which are not. 14. 19. Yeah, it's starting to occur to me now that maybe KiCading is not the most exciting thing to stream. This should have been fairly obvious, but I don't know. Maybe later I make a supercut of just the interesting parts and it will be 10 seconds or something. But this is just more of a way to hang out with people. Let's see if I can get more people to join and hang out with me while I do this. I don't know how to do that, how to get the word out. I mean, I am posting that, I am tweeting that I'm gonna stream. Today it was really short notice because I didn't really plan on doing that. So when I start, yeah, maybe if I start routing, if I'm good, if I'm okay with the routing, otherwise people will just call me out on my crappy routing. But yeah, if I announce it earlier, maybe then more people hang out. I mean, there's quite a few people on Twitter that I interact, okay, like from time to time, so it's nice if they hang out. Yep. But I understand that, I mean, watching a stream, if you actually want to listen and want to interact in the chat, it actually takes almost 100% of your attention, and people have limited time, so can't expect them. It actually might be even more interesting for people when I actually get the board and do the soldering, do the bring up. That probably might be an interesting part for people. But I decided to have the full process from clicking new project in KiCad until I boot Linux and maybe even beyond. Documented for no particular reason really. So I'm streaming this. Yeah, for sure. I mean, this is why I'm also taking my sweet time doing all this schematic work, because later in the process it pays off. So this is, I don't think this is time wasted, making sure everything is correct and having to respin boards because you went too fast to lose. You're a maverick. So yeah, maybe slow and steady. Yeah, I'm not sure if my voice is good for ASMR. It's probably a bit like boring somehow. I feel like my voice, like it just keeps going and going. It's not that engaging. I know some people who stream or do talks have really engaging voice that keeps you interested. But maybe I get better with time. Let's see how that goes. Finally out of the DDR world, although we'll be back very soon actually. I just have to whisper. That's creepy. Let's not do that. Also, I don't have the cool, what is it called? The microphone that's like ears. So that won't give you the nice effect. But maybe I should do it more like Bob Ross, which I haven't watched that much of, so maybe I should watch for guidances. You know, and we have happy little traces that we connect together, and yeah, something like that. But yeah, thank you for joining and hanging out. Have someone to just talk to, bounce off some ideas maybe later. It's really cool. So we're clocking in on 3 hours. I have many pages left. I think I will call this a stream soon-ish. Oh shit. Woo! I thought KiCad crashed again. It's just STM Cube just stole the focus. Ooh, that was, I don't know. It's worse than a scary movie. A jump scare. Especially since I'm kind of concentrated on like reading and checking that. Ooh. Where are we? P10. So yeah, from having like a first quick look at the where the location of the peripherals is, it actually looks pretty alright. But it might be a pain later with the routing that I just can't see it right now. Okay, so it actually generated. I can check that out right now. Yep. So actually here it is. This is the whole directory that Cube generated. So you can see here there's a linker file for the M4. There's IOC, that's the Cube project. There's the report we have been looking at. This is pretty much what was in the PDF. That's probably the same C project. That's for, what is it, True Studio or whatever, for some software they use. And then you get some nice code for the M4. And this is what I'm saying with the code generated by Cube. I mean, because you can change things and regenerate, they have to put these markers where you can actually put your own code that will not be deleted when they regenerate. So there's no real good way to do it, but this is like really annoying, and you wouldn't want this in your final code. So for quick bring up and testing, this is quite alright, but later not so much. And here you can see the clock configuration, which is a bit crazy. Like if you compare it to NRF again, there's like no clock configuration. Clocks are all fixed kind of. So you just set the main clock to 64 megahertz, which it's fixed to that, and you're good. But here you have so many. You have the PLLs that you can have different sources and different dividers and multipliers. So yeah, I'm really glad that actually there's Cube for this. And yeah, here you can see one of the I2Cs. I guess it's the one that I assigned to the M4. It has the settings that I set in Cube, well, the default ones from Cube, but you can change it and it will regenerate those for you, SPI. So quite nice. And yeah, that's the HAL. So this is all startup. What is that's also for the Cortex, isn't it? Yeah, for the Cortex M4. So this is all, exactly. So this is all for the Cortex M4, and then you have the device tree, which is for, yeah, kernel, the U-boot, and VLC, that's right. I'm not sure what this is for. EFA, is that a bootstrap thing? I'm not sure that's gonna give me any results. Yeah, Swedish results. Yeah. Yeah, so I'm not sure. Trusted firmware. Ah, right. Ah, that's for the secure part of the core. Yeah, I guess so. I never worked with these secure parts. That's why I'm not so familiar. But it looks like that is what it is. So here we have the DTS for the Linux kernel. And again, we have these markers because again, it's in each node and in some like nodes here. So it is not super pretty. And also if you look showed white space, see, like consistency is not a thing here. So you don't want to just use this verbatim. That's how you say that. But it is a good base because yeah, it sets up. So here we have the reserve memory for the GPU. It sets up your clocks. It sets up your pin max. Super useful. I mean, you can do this by hand, but this saves you so much time. Sorry, I'm reading. Yeah, reading the chat. So this is really nice to get you started with all the pin max. I mean, this is really the boring parts if you have to do it manually, and this saves a lot of time. Okay, so there's a node for the M4 boxes. I'm not sure what that is. Need to read a lot more. Then system resources. Interesting stuff. I2C, no speed because there. I'm sure you can set it, but it's not in cubes. Setting people up to miss stuff. Possibly. I mean, I think the way I'm gonna do it is I'm just gonna base my DTS on the discovery board DTS and then just change the settings based on this. So like change the pin maxes to be to be the ones generated here. I think that should make sure that I won't miss any peripherals, but that's true. But I guess you can miss some stuff. Anyway, I think as with everything, you have to, you can't just copy blindly. You have to use your brain meat, and yeah, you have to think what you're doing and not just copy. But it is useful if you know what to do with it. We are here. I'm not sure if I touched the USB at all. Yeah, okay, I did. So the OTG seems to be on the USB 2, and then the USB 1 will be the host. Cool. Now I forgot how was the configuration, because one of them was full speed only, but I believe that was when you used right, I have this. It was only if you used 2 hosts, then one of them was full speed and one of them was high speed. That's not a problem for us right now. That voltage probably still has to be assigned, but yep. Okay. But that's not what Cube said, because if I selected 2 hosts, then I couldn't have a OTG at all. It looked like. Disable for now. If I enable this one, exactly, so I can't have high speed, and there's no option for full speed. So either Cube is not ready, like it doesn't have that option to run this at full speed, or this part is, excuse me, this part is wrong. I will trust the datasheet over Cube for sure. But I think I still want a high-speed OTG. So 1 host, 1 OTG. And like I mentioned, in the final thing, I will probably just have the OTG. So it doesn't matter that much. So disable that guy. Re-enable this. And save. And then the whatever. Something is sad here. Or not. Wow, that's not so good. And there we go. Yeah, the Cube support package for this family. This is like the first release, and there might be some bugs. I wouldn't be surprised. And also, you can't set any settings for the peripherals in there if they are connected to the A7 cores. So that's probably something they will add later as well. A15 here. And then it will generate even better DTS files. But high speed, but then, because it clearly says here that you can have 2 high speeds plus 1 full speed, or 2 high speeds, 1 each. So not sure what do they mean, but it's fine. It's not a problem. And AB 5. Oh, that's not right. Oh wait, I did this wrong. This should be here. Just double check. AA14. Yep, I put it on AB. Could I notice? And the wait, this is the last page. I will be actually done, and we are a bit over 2 hours. Cool. So actually, this is really good. Did I miss something here? No, this is looking. A15 was NC. Although it would be good to still connect it just in case I wanted to slap a 1 gig in there. That's probably, I mean, if I don't connect it, then I lose that option. So it's good to have it DRA15. Yeah, there it is. Yeah, right, that's the only thing that changes. Yep. Yeah. So, I mean, at this point, or at least I checked, and it's cheaper to have two 512 meg RAM chips than one 1 gig one. But I mean, it's just one tray, so I wouldn't want to take away that option for myself, just in case. So, and there it is. I'm curious about this one. It is correct. I can actually, or maybe not. Let's leave that for when I do the PMake and the power. That, and this way I know that I haven't done it yet. But these will all be NC. Right. This one I have to double check. The ground is a bit special on the USB because of the shielding resets. Boot, boot I could actually already set it because I know where the, or now I don't know yet where I will put the SD card because there are two SDIOs. Although I would, I think it will be on the one on the left here. On, was it 3? Yeah, so this is 2. And I'm thinking about using that one for the Wi-Fi because the UART for the Bluetooth is right here. So then they can go there somewhere. And then for the micro SD card, I can use these. And then they can go like somewhere here. And it's all good. So it's probably gonna be there. But I can actually leave a note for myself. Boot 0. Exactly this. Oh, how fancy do I want this to be? Not too fancy. He says, and then he proceeds to make it way too fancy, spend way too much time on it. That is way overkill, but whatever. Can I duplicate these? Yes. And then I can duplicate these. That was lucky. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Wow, that was not planned. But it's nice. So give me a 0. I will need to double check this because this is a really bad idea. Perfect to make a mistake. 0001. Yep. 1, 1. I mean, this is. And then all 1. That wasn't so bad actually. High-speed device requires. Okay, so this is important. So that will probably, I mentioned this on a previous stream. The external clock should be 24. Otherwise, you would have to blow a fuse to tell the bootloader what frequency is the crystal. So I think we will go for 24 and let's use the default value. Oh, no, don't freeze. Note to self. Yep, so that's good. So this is UARTs 4, 5, 7, and 8, and USB high speed. And this table is too short. That should do it.
STM32 narrator dialog.
What?
OK. Button. Alt plus O. Schema STM32MP1
Why?
panel. Narrate.
What did I press? Thanks, Windows. Thanks. That was just a bit annoying. That was I do. Okay, so there are default pins as well. See, that's interesting. So I wouldn't have to do this, but I will probably put these as solder bridges, just so I can play around with like the UART and the USB bootloaders. And I should stop ending sentences, questions, because I know it's annoying. Now I see the stream cut up to the narrator incident. So is the SDMMC2, was that the one I was planning to actually? No, it's 3 and 2. See, now that might change my plans actually. If 2 is the default, I think I would rather use the default as the SD card, just in case there are any problems. And then I can still route this out in here. So yeah, note to self, somewhere I just put it. I think I have to make habit of this, making notes, because it's quite useful. What did I say? SDMMC3 for SDIO, and then SDMMC2 for SD. Yep, that will do it. And on the flexible memory controller, no boot for you. Bleed track, thank you for stopping by. Unfortunately, we're almost done with the stream. Like I'm planning to finish it at 2 hours 30, so like 8 more minutes. But I understand that was very short notice, so yeah. But thank you for joining anyway. We can still talk for a few minutes. What is happening? You know, that's this because this differentiates SD card and eMMC, and obviously they use a slightly different protocol. Does that mean you can't have an SD card on MMC2? That would be a bit annoying because MMC1 was not so fun. Let's disable this. But it should be, because I mean I have the choice here, so it was like there, so that's not so fun to route as nice as having them closer. So I might have to read up more on that if you can boot SD card in this mode. Where's 5? Okay. So another 1 or 2 interface can be default in OTP. So this could be a SD card on SDMMC2, but then I have to blow the fuse. That's a bit annoying. Damn. Okay, but let's finish this. It's something to consider. And there we go. And the last one. Yes. So that gives us a nice table, and now I'm actually happy that I had a closer look, because I looked at this in the first stream, but at that point I wasn't aware where the MMC pins are, so I didn't care which one you can boot from. But now that I learned which pins I kind of want to use, it's more important. What? Ah, I did grab. Seriously. What grab like extends it? That's one way to do it. Maybe this is actually more work. Yes, so that's the table right there. It's a nice table. Just save before I move it, because KiCad, I notice it likes to crash when you drag things somehow. And the boot pins, all right, they were here, so that's why I wanted the table here. So yeah, so this is still question mark here, because I need to double check what I want to do. And we have 2 minutes. I'm not sure what more I can do. Oh, that's wrong. So VBAT and all the other guys should go one lower. Like so, and then this has to be dragged. Yep. Okay. Wait, how short? Ah, right. I changed the grid. Changing the grid midway is not fun. I guess that's all right. PMIC. So much time to draw this, and nope. Let's pretend it was worth it. And there's all the GPIOs. Cool. I think that's it. So yeah, we looked at Cube. We selected some of the peripherals. We marked them here. There will be probably more work on that. I showed the DTS being generated. We talked a bit about that. I think overall it was a good stream. We got a bit further in the schematic. Next time, yeah, I guess we finish using the peripherals, and then we can actually start connecting stuff. Like the power, that's gonna be a lot of work. The DDR itself should be fairly straightforward. Actually, let's have that's a bit over time. If there's a symbol for like the DDR, DDR3, no, but it doesn't have to be 3. Memory RAM, which DDR4. But the footprint, I think, seems alright. Wow, why is this disappearing? Great. Anywho, it looks like there will be a symbol that I could kind of base my symbol on. So it should be good on that side. I don't have to create it from scratch. BJ78. Can I search like that? No. Never mind. Okay. Let's not waste time anymore. Oh, tiny LED matrix. Yeah, I'm ending the stream. But no worries. I might stream tomorrow or on Sunday. I'm unsure. But then again, probably on Monday. So there will be many more streams to catch up, or to come and talk with me and hang out and facepalm at my decisions here. So thanks